My name is Reto Meyer, I'm the tech lead for the Android developer relations team at Google, and I'm here to dig beneath the delicious chocolate shell of the latest flavor of Android and into the wafer biscuity goodness at the center of the new developer features. KitKat may only represent a 0.1 increase in version number, but it turns out that a small bump can still include a lot of new features. Where the defining characteristic of Jelly Bean was buttery smoothness, KitKat is all about memory optimization. Android 4.4 is designed to run just as smoothly on a much broader range of devices, including those with as little as 512 megs of RAM. For developers, that means a selection of new APIs and tools to help us ensure that our apps are as memory efficient as the platform. You can start by checking if your app is running on a memory-constrained device using the new is-low-RAM device call on the Activity Manager. Based on the result, you might choose to modify or even disable features with significant memory implications to ensure your app provides a great user experience on devices with memory limits similar to those featured by Guy Pearce's character in Memento. Of course, disabling features is always a last resort, so check out this guide for tips on how you can optimize your app's memory usage without having to sacrifice functionality. But before you can start improving your app's memory efficiency, you need to first understand how you're using memory in the first place. The new ProgStats tool helps you analyze memory resources, providing data about apps' execution durations and memory use. You can access ProgStats from the ADB tool by calling ADB shell dumpsys ProgStats. If command lines make you nervous, fear not! Android 4.4 also includes a new developer option that helps you analyze your app's memory profile on any Android 4.4 device or emulator through the Process Stats developer options screen. Below the system memory summary, there's a list of blue bars indicating the relative computed memory load of each app's process and the relative percentage of time each has spent in the background. Selecting an app displays a summary of the memory consumed and the percentage of the collection interval that this particular app has been running for, as well as the average and maximum RAM usage. It's not all about memory efficiency though. KitKat also includes some new ways to build beautiful apps, starting with some updates to the Android Design Guide, designed to help you create striking, innovative, and distinctive apps that offer users a magical experience. For more details, check out tomorrow's episode of Android Design in Action. In terms of APIs, there's support for a more immersive full-screen experience, a new transition framework for animating scenes, closed captioning support, and a new tool for high-fidelity screen recording. The new full-screen immersive mode lets you create full bleed UIs that reach from edge to edge, hiding all system UI, including the status and navigation bars, and allows your app to respond to touch events from areas that would otherwise be occupied by these system bars. It's a great solution for rich visual content such as photos, videos, maps, books, and games. You can enable this new mode using two new mutually exclusive system UI flags, Immersive and Immersive Sticky. This code shows how to toggle between an immersive full-screen experience within your app using the immersive flag. Alternatively, you can utilize the immersive sticky flag to create a persistent immersive experience that will automatically re-hide the system bars after a short delay, or if the user interacts with the middle of the screen. You can learn more about the new immersive modes, including the best practices for using each alternative in Roman Nurik's immersive mode DevByte. To make it easier to create high-quality animations in your app, Android 4.4 also introduces a new transitions framework for animating between scenes. Now, it's pretty common to use animations to help users understand their progress through UI states, where each state can expose different actions. The new transitions framework helps you define these scenes, typically view hierarchies like these, and the transitions, which define how to animate the transformations between scenes when the user enters or exits them. You can use one of several predefined transition types based on specific properties like layout bounds or visibility, or use the auto transition type to automatically fade, move, and resize views during a scene change. You can also define custom transitions that animate the properties that matter most to your app, or even plug in your own animation styles. For more details, check out the Transitions DevByte from our master of animation, Chet Haas. In an effort to make your apps more accessible, Android 4.4 includes system-wide preferences for closed captioning. Users can now set global captioning preferences, and apps that use video can use those settings to adjust how they present closed captions by using the new Captioning Manager. Apps that use video view can simply pass a captioning stream in WebVTT format along with the video stream for rendering, and the system will handle the display of the captions according to those user preferences. For more details, check out this DevByte by Alan Viverette, the engineer who implemented it all. If you've ever tried to record a demo of your app by holding a video camera very steady, you'll appreciate the new screen recording tool that lets you capture video as you use the device and store it as an MP4. You can record at any device-supported resolution and bitrate, and the output retains the aspect ratio of the display. You can access screen recording through the ADB tool, calling ADB Shell Screen Record, or through the DDMS panel in Eclipse or Android Studio. KitKat also includes a couple of significant new storage API changes, with a new storage access framework and a fully supported SMS content provider. The new storage access framework makes it easy for users to browse and open documents, images, and other files across all of the available local and cloud-based document storage providers. If you develop an app that manages files or uses documents, you can integrate with the storage access framework using the create document or open document intents, and the system will display the standard UI, including content from all the available document providers. If you want to add a storage provider, you implement a new documents provider. Overriding these four methods will let you manage the browsing, reading, and writing of any local or remote data that can be represented as files. Then, you just need to add the documents provider manifest intent filter and request permission to manage documents. And this process will register your provider with the storage access framework and make it available to the standard UI. Then, whenever your app is installed, any app that uses this framework to view or select files will provide access to your content. Our very own Lisa Ray has created DevBytes for both provider and consumer users of the storage access framework, so check them out for more details. Now, if you've been using undocumented methods to provide an SMS-based app, now is an excellent opportunity to familiarize yourself with the official APIs for SMS handling. That primarily involves a newly documented SMS content provider, but also introduces new semantics for receiving messages and writing to the provider. When a message is received, the system routes it directly to the user's default messaging app, using the SMS deliver intent, while other apps can continue to listen for incoming messages using the SMS received intent. Only the default app is able to write new messages to the SMS provider, though other apps can continue to read from it. Apps that aren't the current default can also continue to send messages. Here the system will write those outgoing messages to the provider on your behalf, so that users can still see them in their default app. For more details, check out Adam's DevByte. Also included in Android 4.4 are a number of additions to help your app interact with the real world, including new Bluetooth profiles for Bluetooth HID over GATT, which provides apps with a low latency link for low power peripheral devices like mice, joysticks, and keyboards, and Bluetooth Map for nearby device message exchange. There's also new platform support for built-in IR blasters with a new API that lets you check whether the device has an infrared emitter, query its carrier frequencies, and then send infrared signals. There's also support for host card emulation. HCE adds support for secure NFC-based transactions for things like payments, loyalty programs, card access, and transit passes, by allowing your app to emulate an NFC smart card, though without requiring a provisioned secure element. It also supports a new reader mode to have your app act as a reader for HCE cards and other NFC-based transactions. Android HCE emulates ISO 7816-based smart cards using the ISO 1443-4 protocol for transmission, along with the application identifiers as defined in ISO 7816-4 as the basis for routing transactions to the correct Android applications. There's also native platform support for printing, along with APIs for managing printing over Wi-Fi or cloud-hosted services, such as Google Cloud Print. You can use these new APIs to add printing capabilities for nearly any type of content, from local images and documents to network data or anything that you can render to a canvas. Android uses PDF as its primary file format for printing, so it's best practice to use the helper classes to print bitmaps or to generate a properly paginated PDF version of your content. For convenience, the Printing API provides native and web view helpers to let you create PDFs using standard Android drawing APIs. If your app knows how to draw the content, it can create a PDF for printing it. Nazmul Idris summarizes the best practices for getting started with printing on Android in this DevByte. KitKat also introduces new ways to improve the power use profile of device sensors, starting with sensor batching, a new optimization that delivers sensor results in batches rather than as they are detected. This lets the application processor stay in a low power state until each batch is delivered. You can define the interval at which you receive batches or request immediate delivery of events between batch cycles. There's also 2 new composite sensors, step detection and step counting, both of which were implemented within hardware to help minimize the associated power consumption. Now that's just a small taste of the new APIs available. There's also a completely new implementation of WebView based on Google Chromium that offers the latest in standard support, performance and compatibility, and most of the HTML5 features available in Chrome for Android version 30, plus an updated JavaScript V8 engine. There's also a range of new APIs to better support RTL locales, including drawable mirroring and pseudo locales. Declaring a drawable as auto-mirrorable will allow the system to flip it automatically for users using an RTL locale, preventing you from having to duplicate your assets. Android now also includes an RTL pseudo-locale as a new developer option. The pseudo-locale switches the device to an RTL layout for all locales and displays text in the current language. This can help you find layout issues across your app without having to display the app in an RTL language that you may not be able to read. There's also good news for fans of high-performance computation, with performance improvements to RenderScript and the new ability to take advantage of RenderScript directly from your native code. A new C++ API in the NDK lets you access the same RenderScript functionality available through the framework APIs, including script intrinsics and custom kernels. Last, but by no means least, is a series of security enhancements, including an update to Android's SE Linux configuration, changing from permissive to enforcing, and improved cryptographic algorithms. Elliptic curve digital signature algorithm support has been added to the key store provider, and the script key derivation function is now implemented to protect the cryptographic keys used for full disk encryption. In entirely related news, there is a new device in town, with the launch of the Nexus 5. Check out Google Play for all the details and grab one for yourself, purely for development purposes, of course. The Android 4.4 SDK is now available for your downloading and code updating pleasure using the SDK Manager, and you can get more details on all of the new APIs, features, best practice and every other change at developers.google.com.